Recall that Maclaurin series are your Taylor series when a equals to 0. So Maclaurin series to function of y equals f of x is the following expression: f of 0 plus f prime of 0 over 1 factorial x plus second derivative at 0 over 2 factorial x squared plus and so on. We're using sigma notation, and from 0 to infinity, n of derivative at 0 over n factorial times x to n. So let's find few basic Maclaurin series. First example, if our function equals e to x, and if we want to find Maclaurin series for it, then we recall that all the derivatives of e to x is just e to x. Now if we evaluate the derivative at 0, we're going to get 1. So our Maclaurin series for e to x is 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus and so on. If we want to find Maclaurin series for cosine x, we need to find nth derivative of cosine x to start with. Our initial function is cosine x. Our first derivative is negative sine x. Second derivative is negative cosine x. Third derivative will be sine x. Fourth derivative will be cosine x. Now if we want to evaluate them at a equals to 0, we're going to get 1, 0, minus 1, 0, 1, and so on. So we figure out our coefficients for Maclaurin series. So we can write Maclaurin series for cosine x as 1 plus 0 plus negative 1 over 2 factorial x squared, because when n equals to 2, plus 0 plus when n equals to 4, 1 over 4 factorial x to 4, and plus and so on. So we got Maclaurin series for cosine x equals 1 minus x squared over 2 factorial plus x to 4 over 4 factorial. And we kind of know this pattern. Next one could be minus x to 6 over 6 factorial plus and so on. Or using sigma notation, Maclaurin series for cosine x is going to be infinite series from 0 to infinity, negative 1 to n, x to 2n over 2n factorial. A few basic Maclaurin series which we want to remember. Maclaurin series for e to x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus and so on, over sigma notation x to n over n factorial, when n is from 0 to infinity. Maclaurin series for cosine x. For cosine x, we're going to go by even powers, and we're going to alternate between positive and negative signs. So we start with positive 1, then minus x squared over 2 factorial plus x to 4 over 4 factorial minus x to 6 over 6 factorial plus x to 8 over 8 factorial, and so on. Or using sigma notation, negative 1 to n, x to 2n over 2n factorial, and starts at 0, that's infinity. Similar series for sine x, Maclaurin series for sine x, is going to be, instead of going by even powers as we did for cosine, we'll go by odd powers for sine, and we're going to get x minus x cubed over 3 factorial plus x to 5 over 5 factorial minus x to 7 over 7 factorial plus x to 9 over 9 factorial minus and so on. or using sigma notation, n from 0 to infinity, 2n plus 1 factorial, and x to the 2n plus 1, because we want to go by odd powers, and -1 to n. Those are three basic Maclaurin series which we want to remember. We're going to add a couple more to it, particularly general binomial theory. If we want to find Maclaurin series for x times e to x, what we'll do is we're going to write down Maclaurin series for e to x, which is 1 plus x squared over 2 factorial plus and so on. And then we're going to distribute x inside, so we're going to get x plus x squared plus x cubed over 2 factorial plus x to the 4 over 3 factorial plus and so on. If we want to find Maclaurin series for e to x squared, what we'll do is we're going to write down Maclaurin series for e to x, or e to the u, and instead of u we're going to write x squared. So recall Maclaurin series for e to x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial. So any and everywhere we see x, instead of x we're going to write down x squared, so we're going to get 1 plus x squared plus x squared over 2 factorial plus x squared cubed over 3 factorial plus and so on. We're going to get 1 plus x squared plus x to the 4 over 2 factorial plus x to the 6 over 3 factorial plus and so on. If we want to get Maclaurin series for cosine of x squared, we're gonna be using trig identity, which says cosine of x squared equals to 1 plus cosine of double argument over 2. So we're going to get 1/2 plus 1/2 cosine of double argument, which equals 1/2 plus 1/2. And we're going to write down Maclaurin series for cosine of 2x. And Maclaurin series for cosine of 2x we are familiar with, so it's going to be 1 minus 2x over 2 factorial plus 2x squared, 2x to 4 over 4 factorial minus 2x to 6 over 6 factorial plus and so on. We're going to simplify that expression slightly, so we're going to get 1/2 plus 1/2, 1 minus 4x squared over 2 plus 2 to 4 is 16, 16x to 4 over 4 factorial minus 2 to 6 is 64, x to 6 over 6 factorial. And maybe we will bring 1/2 inside, but finally our answer is going to look something like this. 1/2, 1 plus 1 is 2, 2 minus 2x squared over 2 factorial plus 2x to 4 over 4 factorial minus 2x to 6 over 6